National Electrical Code, Article 300.7b states fluids other than air shall not be present in quantities sufficient to cause damage. Article 408.1 states electrical equipment shall be installed in a suitable enclosed space or cabinet that is ventilated and protected from water, falling dirt, and other damage. NFPA 70E requires electrical equipment to be maintained in a safe condition free from physical damage and water infiltration. IEEE 399 recommends that transformers be installed in separate enclosures when subjected to moisture or other hazards. Many electrical equipment manufacturers require specific clearances and protection from water sources for their products based on underwriters' laboratory standards. It is generally not recommended to install water feed and return lines inside electrical panels unless absolutely necessary. If this is unavoidable, the following best practices should be followed. Firstly, use sealed connections and fittings to prevent water leakage. Secondly, keep the lines as short as possible and away from electrical components. Thirdly, use a drip pan or water collection tray to catch any leaks. Fourthly, ventilate the panel to prevent moisture buildup. And fifthly, monitor the system regularly for any signs of water infiltration. While it is not explicitly required by code, it is often advisable to locate transformers in separate panels for several reasons. Firstly, safety. Transformers can generate heat and create electrical hazards. Separating them from other electrical equipment reduces the risk of fire or explosion. Secondly, accessibility. Separate panels allow for easier access to transformers for maintenance and repair. And thirdly, protection. Enclosing transformers in separate panels provides additional protection from moisture, dust, and physical damage. Adhering to these guidelines and best practices helps ensure electrical safety and equipment longevity. The National Electrical Code sets the foundation for electrical safety in buildings. It is updated regularly to address new technologies and safety concerns. Article 300.7b focuses on protecting electrical equipment from damage caused by fluids, emphasizing that fluids other than air should not be present in quantities sufficient to cause harm. This is particularly relevant when considering the proximity of water lines to electrical panels. Article 408.1 provides further guidance, requiring that electrical equipment be installed in enclosures that protect against water, dirt, and other potential hazards. These enclosures should also be adequately ventilated to prevent moisture buildup. NFPA 70E, standard for electrical safety in the workplace, emphasizes the importance of maintaining electrical equipment in a safe condition. This includes ensuring that equipment is free from physical damage and water infiltration. Water infiltration can lead to corrosion, short circuits, and other electrical hazards, making regular inspections and maintenance crucial. IEEE 399, the Brown Book, offers recommendations for power system design and operation. It suggests that transformers should be installed in separate enclosures when they are likely to be exposed to moisture or other environmental hazards. This helps to protect the transformers and prevent potential failures. Underwriters Laboratories UL develops standards and certifications for electrical equipment. Many manufacturers require specific clearances and protection from water sources for their products to maintain their UL listing. These requirements should be carefully considered when installing electrical equipment near water lines. When installing water lines near electrical panels, it is essential to follow best practices to minimize the risk of water damage and electrical hazards. Using sealed connections and fittings is crucial to prevent water leakage. All connections should be properly tightened and inspected regularly for any signs of leaks. Keeping the water lines as short as possible and away from electrical components reduces the likelihood of water coming into contact with sensitive electrical parts. The lines should be routed in a way that minimizes the risk of damage from accidental contact or impact. Installing a drip pan or water collection tray beneath the water lines can help to catch any leaks and prevent water from spreading to other areas of the electrical panel. The tray should be made of a non-conductive material and should be regularly inspected and emptied. Ventilating the electrical panel helps to prevent moisture buildup, which can lead to corrosion and other problems. Ventilation can be achieved through natural convection or by using fans or other mechanical ventilation systems. Regularly monitoring the system for any signs of water infiltration is essential. This includes inspecting the panel for water stains, corrosion, and other signs of moisture damage. If any signs of water infiltration are detected, the source of the leak should be identified and repaired immediately. While it is not always required by code, locating transformers in separate panels is often advisable for several reasons. Transformers can generate significant amounts of heat, which can increase the risk of fire or explosion if they are located in close proximity to other electrical equipment. Separating the transformers from other equipment reduces this risk and improves overall safety. Separate panels allow for easier access to the transformers for maintenance and repair. This is particularly important for large transformers that may require specialized equipment or procedures. Enclosing transformers in separate panels provides additional protection from moisture, dust, and physical damage. This helps to extend the lifespan of the transformers and reduce the risk of failures. The National Electrical Manufacturers Association NEMA provides standards for electrical enclosures. NEMA enclosures are designed to protect electrical equipment from various environmental hazards, including water, dust, and corrosion. Choosing the appropriate NEMA enclosure for an electrical panel can help to ensure that the equipment is adequately protected. Proper grounding is essential for electrical safety. All electrical panels and equipment should be properly grounded to prevent electrical shock hazards. The grounding system should be regularly inspected and tested to ensure that it is functioning correctly. Regular inspections and maintenance are crucial for ensuring the safety and reliability of electrical systems. Electrical panels should be inspected regularly for signs of damage, corrosion, and water infiltration. Any problems should be addressed promptly to prevent potential hazards. Electrical work should only be performed by qualified and licensed electricians. The electricians have the training and experience necessary to safely install, maintain, and repair electrical equipment. They are also familiar with the applicable codes and standards. The use of surge protection devices can help to protect electrical equipment from damage caused by voltage surges. Surge protection devices should be installed at the main electrical panel and at individual equipment locations. Proper labeling of electrical panels and equipment is essential for safety. All panels and equipment should be clearly labeled with their voltage, amperage, and other relevant information. This helps to prevent accidental contact with energized equipment and facilitates maintenance and repair. The installation of arc fault circuit interrupters, or FSIs, can help prevent electrical fires. FSIs are designed to detect arc faults, which are a common cause of electrical fires, and to quickly shut off the power to the affected circuit. GFCI, or ground fault circuit interrupters, are designed to protect people from electrical shock. They do this by monitoring the current flowing through a circuit and quickly shutting off the power if a ground fault is detected. GFCIs are required in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor locations. Regular training on electrical safety is essential for all employees who work with or around electrical equipment. Training should cover topics such as electrical hazards, safe work practices, and the proper use of personal protective equipment. Wearing appropriate personal protective equipment, or PPE, is essential for protecting workers from electrical hazards. PPE may include items such as gloves, safety glasses, and insulated tools. The use of lockout/tagout procedures is essential for preventing accidental energization of electrical equipment during maintenance and repair. Lockout/tagout procedures involve disconnecting the equipment from its power source and attaching a lock and tag to the disconnect switch to prevent it from being accidentally turned on. Emergency procedures should be in place to address electrical accidents and incidents. These procedures should include steps for contacting emergency services, providing first aid, and shutting off the power to the affected area. A comprehensive electrical safety program should be in place to address all aspects of electrical safety. The program should include policies, procedures, and training to ensure that electrical work is performed safely and in compliance with applicable codes and standards. Using thermal imaging cameras can help identify hotspots in electrical panels and equipment. These hotspots may indicate loose connections, overloaded circuits, or other problems that could lead to equipment failure or fire. Power quality monitoring can help identify voltage fluctuations, harmonics, and other power quality problems that can damage electrical equipment. Power quality monitoring equipment should be installed at the main electrical panel and at critical equipment locations. Energy audits can help identify opportunities to reduce energy consumption and improve the efficiency of electrical systems. Energy audits should be performed regularly by qualified professionals. Implementing energy-efficient lighting can significantly reduce energy consumption and lower electricity bills. Energy-efficient lighting options include LED lighting and compact fluorescent lamps, or CFLs. Proper maintenance of electrical equipment can extend its lifespan and improve its reliability. Maintenance activities should include regular cleaning, lubrication, and inspection of all components. Regular testing of electrical systems can help identify potential problems before they lead to equipment failure or safety hazards. Testing activities should include insulation resistance testing, ground impedance testing, and circuit breaker testing. Proper ventilation of electrical rooms is essential for preventing overheating and ensuring the proper operation of electrical equipment. Ventilation systems should be designed to provide adequate airflow and to remove heat generated by the equipment. Keeping electrical rooms clean and free of clutter is essential for safety. Clutter can obstruct access to equipment and increase the risk of fire or other hazards. Regularly reviewing and updating electrical safety procedures is essential to ensure that they remain effective and relevant. Procedures should be updated to reflect changes in technology, codes, and standards. Communicating electrical safety information to all employees is essential for raising awareness and promoting a culture of safety. Information can be communicated through training sessions, safety meetings, and written materials. Encouraging employees to report electrical safety concerns is essential for identifying and addressing potential hazards. Employees should be provided with a confidential and non-retaliatory mechanism for reporting concerns. Working closely with local utilities and electrical inspectors can help ensure compliance with applicable codes and standards. Utilities and inspectors can provide valuable guidance and support on electrical safety matters. Staying up to date on the latest electrical safety technologies and best practices is essential for maintaining a safe and efficient electrical system. This can be achieved through ongoing training, attending industry conferences, and subscribing to relevant publications. The presence of water near electrical equipment is a serious hazard that should be addressed promptly and effectively. By following the guidelines and best practices outlined above, it is possible to minimize the risk of water damage and electrical hazards and to ensure the safety and reliability of electrical systems.